Welcome to the second part of emitter follower configuration circuit analysis. And for this session, we will solve an example of electronic emitter follower configuration. Now, for this example, this is from our textbook, Electronic Devices and Circuit Theory by Robert Boylestad and Shosky. For this example, we have R sub B equivalent to 240K. R sub E is 2 kilo ohms. Supply voltage of VEE equivalent to negative 20 volts. And our beta is 19. So we will solve the different circuit currents and circuit voltages or terminal voltages. Now, from our previous discussion, this is how we arrived with the equation for IB. If you're not familiar, if you would like to see how we were able to arrive at this equation, you can watch the previous session. Now, for now, we will now determine I sub B. So base current natin is equivalent to VEE, so that's 20 volts. Okay, minus VBE, which is 0.7 volts. And R sub B is 240,000 ohm. Yeah, and then plus beta of 90 plus 1. And R sub E of 2 kilo ohms, so that's 2,000 ohm. And of course, this will give us an IB of 4 point, or this is somewhere near 45 in terms of microamperes, plus 45.735 microamperes. So meaning we have a current flowing this way, which is your IB at 45.735 microamperes. Next, you can also solve for I sub C. So I sub C would be a current flowing this way. Okay, so towards your ground. So meaning, using the same equation, so I sub C is equal to beta times I sub B times I sub B. Okay, so that's equivalent to 90 times IB. So our IB is 45.735 microamperes. Multiply it by 90, so that's equivalent to what in terms of milliamperes? That's 4.116 milliamperes. So that's the amount of current flowing through your collector terminal. How about your I sub E? So I sub E is equivalent to what? Beta plus 1 multiplied by I sub B. So we're expecting it to be close to your collector current. And of course, your beta, of course, is 90. Yeah. This will give us what? In terms of milliamperes, so we have a current of 4.162 milliamperes. So yun naman yung this is the amount of current flowing in this direction. So that's your RE. Now to determine the terminal voltage, the easiest of the three would be of course, VC. So if you have a voltmeter and you would like to determine you would like to determine the collector voltage. So we have V, and then right here you're going to collect your positive terminal on your collector terminal if you would like to measure collector voltage. And our negative terminal to your ground. So as you can see, we do not have any potential difference. So meaning your collector voltage is equal to 0. So V sub C therefore is equal to 0 volts. So that's your V sub C. So as you can see, it's the easiest of the three. Now for VB, or collector base voltage, as you can see, we're using this loop uh, previously to solve for IB. So this is the location of your base terminal. Okay. So if you have a voltmeter and you would like to measure the base voltage, so you're going to measure positive terminal of your voltmeter to your base terminal, and the negative terminal to ground, to our reference. So this is similar with placing your voltmeter across this terminal, which is the voltage across RB. Okay, so we're simply measuring the voltage across RB. And to measure this part, okay, so following our loop previously, so that means for the base voltage, okay, so we started with 0. So meaning, again, so that's 0 minus VRB, or the voltage across resistor RB. So it's equivalent to your V sub B. So this is where you're going to stop. Okay. So meaning V sub B, or base voltage, is equal to negative of this RB, which happens to be IB times the resistance, which is R sub B. Okay. So meaning our V sub B, therefore, or the correct base voltage, is equal to negative I sub B, which is, in our case, I sub B is 45.75 microamperes, times R sub B, which is 240,000 ohm, and this will give us negative 10.76 volts. So negative 10.76 volts. You're expecting a voltage readout somewhere near 10.976 volts negative. So that's base voltage. Now to determine the last circuit voltage, or terminal voltage for our BJT, we're going to measure V sub E, which is the emitter voltage. So you're going to connect the positive terminal of your voltmeter on your emitter terminal, and of course the negative terminal to your ground or reference terminal. Now we cannot use IE times RE, since V sub E actually covers the voltage across resistor RE and your VEE. So meaning that's RE and VEE in total. So if you'd like to measure VEE, V sub E, or emitter voltage, so that is simply, if you're going to follow our loop going this way, so that would mean 0 minus the voltage across RB minus VBE, and at this point, that is your V sub E. Okay, so we can do that. Let's say 0 minus VRB minus VBE is equivalent to V sub E. So again, V sub E is not equal to IERE, kasi if you're going to say that VE is equivalent to IERE, so that means you're going to place your voltmeter similar to this one. So if you're going to say that VE is equivalent to IER, that's the common mistake, no? With this network. So please, V sub E, or emitter voltage, is not the same with IERE. So simply because V sub E covers or includes the supply voltage VE. Okay, so by using this loop, you can now solve for VE. So VE, now as you can see, this part right here is equivalent to what? Your VB minus VBE. So para ka lang yung VB, you simply added minus VBE. Okay, so which means we can simply say that VE is equivalent to V sub B minus VBE. And we know that VB is negative 10.976. So we will simply minus 0.7 volt. Okay, so subtract 0.7 volt to the existing base voltage. And this will give us 11.676 volts. So that's your VE. Now for common emitter configurations such as this, you will always be asked to solve for VCE. So VCE is a very important parameter. So as what we've done previously, this is simply the difference between collector voltage and emitter voltage. So we know that the collector voltage is 0 and V sub E is negative 11. So therefore VCE is 11.76 volts. And that's it. That's all the circuit currents and terminal voltages for emitter follower or common collector configuration.